Hello everyone, today we will talk about student eating habit and food spending pattern for probability and statistics. First, we will talk about why we study with topic. For our project, focus on understand student food behavior from three key angles. First, health insight. We look at how eating habit relate to BMI and health risks like obesity and diabetes. We also spot trend in the healthy versus unhealthy food choice. Second, financial behavior. We explore how studies spending money on food, whether they prioritize convenience or try to save money. Third, lifestyle performance. We examine cultural influence like choosing Thai or Western foods and whether students tend to eat our cook at home. The ultimate goal is to empower students to make the healthier and more budget-friendly food decisions, while also giving induction data to support student well-being. Next, how we collect data. For data collection, we use online survey by designing equation focused on eating habit and foods. Explain using Google Forms. We share the survey link through version social media platform, including Line, Instagram, Facebook, Discord, and other online channels to reach a broad range of cities. Next, who survey response come from? Our primary target group is university and college study, typical between 18 to 20 years old. We recruit participants through multiple channels online. We reach our university group chat, study group, and friend circle. On Instagram and Facebook, we connect with the student community and personal network. And on Discord, we share the survey in study group and gaming community where many students are active.
The next topic is descriptive statistics and distributions. Here is the overall data for students' opinion on their food consumption health quality. This represents it through pie graph shows that half of students think that their diet style is normal. Around 25% think that it is unhealthy and others are healthy, and very unhealthy. Another interesting fact is almost half of students regularly eat with their friends, while the number of those who eat alone with parents with lovers are slightly the same amount. Next is the bar chart of people's favorite type of cuisine. The most favorable one is Japanese food, then it comes with Thai, Western, Chinese, Korean, and Indian food. Next is the amount of money students spend on their food per meal. For the goodness of its taste, we make the hypothesis that the data of how much students spend on food per meal is uniformly distributed with parameters maximum 375 and minimum 25. The alternative hypothesis is the data of how much students spend on food per meal is not uniformly distributed. Given the significance level 0.01, and the conclusion is since the test statistic falls into the rejection region, we reject the null hypothesis. Therefore, the data of how much students spend on food per meal is not uniformly distributed. Here's a table of descriptive statistic and distribution. The mean is equal to 107.865 and the standard deviation is 61.69.
Okay, here is goodness of faith test about students' willingness to pay for their favorite single meal. Hypothesis. Now hypothesis, the data of how much students are willing to spend when it comes to the food they like is normally distributed with parameters mean equal to 550.886 and sigma equal to 1168.073. Okay, alternative hypothesis, the data of how much students are willing to spend when it comes to the food they like is not normally distributed. In conclusion, the test statistics fall into the rejection region, so the null hypothesis is rejected. This means the data of how much students are willing to spend when it comes to the food they like is not uniformly distribute within the range of 50 to 100,000 baht. However, this result may be influenced by the presence of a significant outlier which could skew the distribution. Here is descriptive statistic and distribution of it. Contains measure of centrality, measure of dispersion, and outliers. Okay, here is goodness of fit test of frequency of eating out or ordering takeout per week. Hypothesis. Now hypothesis, when the data of times per week students eat out or take out follows a uniform distribution with a minimum of 1 and maximum of 21. Alternative hypothesis. The data of times per week students eat out or take out doesn't follow a uniform distribution which gives significant level of 0.01. In conclusion, the test statistics fall into the rejection region, so we reject the null hypothesis. The data does not follow the uniform distribution with parameters minimum equal to 1 and maximum equal to 21. We also adopt the value 500 as it appears to be an outlier. Okay, last one is goodness of fit test of amount students spend on sweets and snack per week. The hypothesis will reject when the data of times per week students eat snacks or dessert is uniformly distributed with parameters maximum equal to 21 and minimum equal to 0. Alternative hypothesis. The data of times per week when students eat snacks or desserts is not uniformly distributed given significant level to 0.001. In conclusion, the test statistics fall into the rejection region, so the null hypothesis is rejected. This means that the data of time per week when students eat snack or desserts is not uniformly distributed within the range of 0 to 21. And here is descriptive statistics and distribution, which contains measure of centrality, measure of dispersion, and outliers.
And now we are going to find the correlation between regular meals spending and on preferred meals. We set attribute X for the amount students spend on food per meal and attribute Y for how much students are willing to spend on meals they actually enjoy. From our calculation in table, the correlation coefficient between X and Y attribute is 0.1. This weak positive correlation indicates that while students who spend more on regular meals tend to spend a little more on special meals. Now we are testing whether the average body mass index or BMI of university students is below 22.9, which is considered the normal range. We set up our hypothesis. The null hypothesis assumes that the average BMI is below 22.9, and the alternative hypothesis suggests it not. We will test this using a one-sample C-test using the formula in the slides. From the sample, the calculated C-value is allowed minus 3.9. The critical C-value at 0.01 significant level is allowed 2.33. Since our minus C value is less than this, we reject the null hypothesis. We conclude that the average BMI of university students is below 22.9, indicating that they are in the normal wage range. Thank you. Okay. Thank you for your attention. Here's our group members.